Saturn has been a source of fascination for scientists since its discovery. One of the most fascinating aspects of this planet is its amazing ring-like structure. Notable luminaries like Galileo, Huygens, and Cassini, as well as ordinary fans like amateur astronomers, have long been captivated by the charm of the Lord of the Rings. With exploration missions sent to Saturn, like as Voyager and Cassini, we now have a thorough understanding of its substructures, including its moons and rings. While we've gotten accustomed to seeing Saturn's magnificent display of rings, what if I told you that they will soon vanish from our view? Join me in viewing this video to learn how and when this is likely to occur. The Lord of the Rings. Saturn, visible to the naked eye since prehistoric times, fascinated ancient civilizations. Around 700 BCE, the Assyrians characterized it as a glimmer in the night and dubbed it the Star of Ninip. Later, about 400 BCE, ancient Greek astronomers named the wandering star Saturn in honor of Kronos, the agricultural god. The Romans later took this name. Then in 1610, Galileo made a revolutionary observation. His telescope revealed Saturn's strange rings, which confused him at first. They looked like arms. Galileo even theorized about enormous moons on either side of Saturn, only to discover later that he was looking at the rings edge-on. Galileo's telescope was fairly basic. Saturn would look like a hazy object in the sky. He even tried drawing what he saw. Here is his drawing. In 1659, Christian Huygens, using improved telescope optics, discovered that Saturn's arms were actually a ring system. Huygens also discovered Saturn's moon Titan, and the probe that explores it bears his name. In 1675, Jean-Dominique Cassini found large moons in the well-known Cassini division. Over the centuries, further discoveries were made. In the 19th century, J. E. Keeler discovered that Saturn's ring system is made up of tiny particles rather than a homogeneous sheet. Saturn, with its butterscotch-colored hue, is the sixth planet from the Sun and the second largest in the solar system. Fast forward to present, for robotic spacecraft have visited, beginning with Pioneer 11 in 1979. Pioneer, launched in 1973, laid the groundwork for future space exploration. Launched on April 6th, it arrived at Saturn on September 1st, 1979. This incredible probe delivered crucial information about Saturn's atmosphere and magnetic field, as well as the discovery of 2 new moons. Years later, the Voyager missions, with Voyager 1 launching on September 5, 1977, and Voyager 2 on August 20, 1977, undertook thorough observations of Saturn's atmosphere, rings, and moons. Voyager 1 showed the complicated structure of Saturn's rings, while Voyager 2 supplied more information about its moons. Cassini-Huygens arrived in 1997. This probe was a game-changer. It arrived at Saturn on July 1, 2004, and orbited the planet for approximately 13 years, examining its rings and moons. Cassini's Huygens lander landed to Titan, Saturn's largest moon, delivering crucial information on its chemical composition and development. Cassini's grand finale in 2017 marked the intended conclusion of its mission, which involved falling into the planet's atmosphere. This phase revealed unparalleled information about the planet's atmosphere, gravitational field, rings, and moons. And this is exactly what we are going to discuss. Join us in the next installment as we explore deeper into the secrets of Saturn's rings, its several moons, and the ongoing research that shapes our understanding. Once the Earth had a ring. Saturn, nicknamed the Lord of the Rings because to its spectacular ring system, has captivated scientists for centuries with its heavenly majesty. This gas giant stands out for its exquisite rings, making Earth envy of its ringless status. The Roche limit, a critical notion in understanding ring formation, is also responsible for this. It is the smallest distance at which tidal forces keep celestial bodies from colliding. Saturn's rings remain safely within its Roche limit, allowing them to exist without merging with the planet. If an asteroid or moon crossed this limit, it would begin to shatter into parts of all shapes and sizes, which would eventually orbit the gas giant. Saturn also has a large number of moons, each of which has its own influence on the ring system. Previously, it was thought that gravitational interactions between these moons and drifting debris aided in the development and preservation of the rings. However, current study reveals that these moons' dynamic actions may cause the rings to gradually fade. For example, the James Webb Space Telescope's most recent discovery reveals a likely occurrence of this event on Uranus. Saturn, like Uranus, is reportedly slated to part ways with a major section of its rings in the near future, but for a completely different cause. Continue watching this video to find out what exactly is causing this approaching event. It's vital to remember that Earth's Roche limit is significantly closer to the planet than Saturn's. As a result, asteroids can approach Earth several times without being destroyed by physical loss. Furthermore, the tidal pressures produced on Earth by the Moon, Sun, and other planets have been found to be detrimental to the creation and stability of large ring systems. Furthermore, in order to be destroyed at the Roche limit, material must be available. It's possible that Earth didn't have enough material during its development to form a ring. The planet did not get large enough to attract material that could form a stable ring. It is also worth mentioning that the majority of Saturn's rings are made of ice, which is unstable closer to the Sun. Nonetheless, scientists know that Earth originally had a ring, presumably made of its own planetary material and believed to have formed when a massive celestial body collided with our planet in its early phases. As a result of this collision, Earth briefly had a ring-like structure that eventually merged into the celestial body we now know as the Moon. Anyway, although Saturn proudly exhibits its rings, planets like Earth are ringless. This is the splendor of the cosmos we inhabit. Each celestial body exhibits unique characteristics determined by its composition, distance from the Sun, and gravitational dynamics. What Cassini discovered about Saturn's rings. As I previously stated, Cassini's mission was a game-changer in the study of Saturn rings. Its voyage revealed incredible ring-moon interactions, letting us to observe the dance of heavenly bodies. The probe witnessed Saturn's lowest ring temperature ever recorded, revealing the chilling beauty of the ringed planet. Cassini's discovery that the Moon Enceladus was the source of the so-called Saturn's E-ring was a significant finding. This moon, by releasing icy particles into space, provides a dynamic layer to the Saturnian ring system, highlighting the system's interwoven beauty. NASA's investigation thoroughly investigated the size and distribution of ring particles. The spacecraft solved the mysteries of these frozen pieces, which ranged in size from less than a grain of sand to the size of solid mountains, by observing how the light of distant stars changes as it passes through the rings and how our sun's light reflects off them. The rings, which are around 30 feet thick and made up of billions of water ice particles, served as Cassini's canvas for investigation. The probe observed some of Saturn's moons stealing and adding particles to the rings, demonstrating the complex dynamics at work. The Cassini mission observed phenomena such as propellers several thousand miles long caused by the gravitational effect of moonlets. These ring material lumps, which are smaller than moons but larger than individual particles, ejected surrounding ring particles, revealing fascinating features. The spacecraft's instruments captured unusual characteristics like spokes, fingers, and radial formations within Saturn's rings. These spokes, believed to be microscopic ice particles pushed above the surface by electrostatic charge, added a sense of mystery and dynamic beauty to the majestic ring behemoth. Saturn, like Earth, has seasons, although each one lasts approximately 7 to 8 Earth years. Can you imagine the difficulties of enduring a 7-year winter? Fortunately, spring ultimately appears on the globe. The equinox signifies the change from winter to spring, when day and night last the same amount of time. Equinox events gave Cassini a unique perspective on Saturn's rings, revealing innumerable ice clusters casting massive shadows. Temperature fluctuations observed during the equinox offered important insights into the composition and properties of ring particles. Cassini's discovery have added numerous layers to the enthralling story of Saturn's rings, from spokes and clumps to propellers, moonlets, rings giving birth to moons and moons producing rings. As we marvel at these celestial beauties, we can't help but wonder how Galileo would have reacted to the fascinating sights that Cassini has made available to all of us. The disappearing rings. Saturn's rings will appear to disappear in 2025 due to the planet's movement on an axis. Saturn's rings will not disappear in 2025, but they will be edge-on, making them virtually invisible to Earthlings, NASA revealed to CBS News. The rings will be barely visible in the months leading up to and following the edge-on collision. How is that even possible, you might wonder? It's a matter of perspective. Because the planet rotates on a 26.7-degree slanted axis, the perspective of its rings from Earth varies with time, according to Vahe Perumian, a physics and astronomy professor at the University of Southern California who spoke with CBS News via email. Every 13 to 15 years, Earth encounters Saturn's rings edge-on, which means they reflect relatively little light and are extremely difficult to observe, rendering them nearly invisible. The rings were last edge-on in 2009 and will be perfectly edge-on on March 23, 2025. It also occurred in 1995. This is how they looked back then. Both photos were acquired with Hubble's Wide-Field Planetary Camera 2. The higher image was captured in visible light, however the lower image depicts Saturn's disk differently. This variance results from the use of a narrowband filter, which selectively allows light unaffected by methane gas absorption in Saturn's atmosphere to pass through. Despite Saturn's distance of almost 900 million miles, Hubble was able to identify details as small as 450 miles. This form of observation was used to determine the timing of the ring plane crossing, the thickness of the primary rings, and to look for prospective undiscovered satellites. The amazing thing is that Cassini physically approached the target years later and directly measured these measurements. In any case, don't worry. After going edge-on in 2025, the rings will be visible again a few months later. Alright folks, this video ends here. Thanks for watching. So, are you ready to see Saturn's rings disappear? Please let us know in the comments below, and I will see you next time on the channel.